So welcome everyone. My name is Keith Baxelbaum. I'm a data science supervisor in the data science and biostatistics unit. And I'm gonna present Reshaping Data with Tidyr today. This is part of the R102 series I've been working on with my brilliant colleagues, Rose Hartman and Alexis Zavez. Just a couple pieces of information on this. In the chat for the meeting, there's a whole bunch of information for you. So there's links to the GitHub repo with all the information from the whole series up to this point. There's today's slides if you want to follow along with the slides. And there's also a link to a Posit Cloud project if you want to use or do some of the R challenges as we go along. You can link to that account and do it online. You can also, if you'd rather do it on your machine, you can get the exercises from the GitHub repo on that slide. Also, please feel free to use the chat as we go along. If you have questions, there's a bunch of really great R experts that are in today's talk that will be happy to answer those questions. And the things I need to address, I'm happy to answer them as I can as well. Some tips if you do decide to follow along with the slides through that link in the chat. There's some shortcuts you can use, so you can advance using the forward and backward arrows. If you want to see the speaker notes that I have for some of the slides to get more information, you can hit S, and then you can question mark if you want to see some other keyboard shortcuts or learn more about how to use Quarto to make presentations in R. I've got a handful of housekeeping announcements before we get into today's topic. One is there's a really fantastic and vibrant CHOP R user group. So if you are a CHOP community member or a Penn community member, consider joining the CHOP R user group. It's a really great resource to get extra information. If you have questions about anything you're doing in R, if you want to just connect with other people who are doing R. Also, it's a great place to learn about webinars and things like that. There's a link to join on this slide, and it's like Rose just added that link also to the chat, so definitely consider joining it. It's very low-key and just a really nice resource to have. Additionally, there's R office hours that are hosted through the R user group. So this is a great opportunity if you want to learn more about how to use R, if you want some help from an R expert on your code, if you just need a one-on-one talk about things from your projects, consider signing up for office hours. There's a link here. There's also a link again in the chat to a calendar to sign up for if you want to join office hours, or if you're a more experienced R user and you would be interested in hosting office hours, you can contact Rose. Her email is on this slide, and talk to her about being able to host office hours as well. In this session, so this is the third talk in a series called R102, Mastering the Fundamentals. So this has been a series of talks about getting a little beyond the basics of R to do some more kind of nitty-gritty things in manipulating your data, getting things ready for analyses, things like that. The next presentation for this is going to be in about a month on June 3rd. That's going to be on data types and visualizations. So if you want to learn a good deal more about how to make really nice publication-ready figures, things like that, how to deal with different kinds of data types, get those ready for making visualizations, that's going to be a really useful session as well. So definitely consider coming. If you have colleagues who you think would be interested, let them know as well. We also do record these talks and post them on the GitHub. So if you can't make it, you can still check out the talk afterwards. A couple more pieces of housekeeping. There was recently discovered there's some vulnerabilities in a previous version of R. And so it's highly recommended if you have been using R on your personal machine to update to the most recent version. So that's version 4.4.0. So make sure if you do have R on your machine to update to that. There's some details on the vulnerabilities at this link, but just it's important to make sure that you have the safest version. And then finally, a shameless plug. So I mentioned I'm a data science supervisor in the Data Science and Biostatistics Unit, or the DSPU. If you have a funded research project and you need some additional help with your data, kind of any capacity, whether it's you want to talk to a biostatistician about the right statistical approaches, you need help running those statistical approaches, you need help managing your data, any of these things, we're always looking for new collaborators. So feel free to reach out to us. You can reach out to either Alexis, whose email's here, or me, and we're happy to talk to you about what our services entail and how we can help you. So keep that in mind. Okay, now that that's all out of the way, let's get to what we're actually here to talk about today, which is reshaping data with the Tidyr package in R. So today's talk is going to be a relatively quick primer on some tools that we have for data manipulation. If you've had a little exposure to R before, so for example, if you've gone through the Intro to R for Clinical Data workshop, or kind of colloquially the R101 workshop that's been offered through the R group at CHOP, this should be hopefully at the right level for you. So we're going to assume a little bit of background knowledge of R. If you're completely brand new to R, that's great. And I encourage you to follow along. Some of the things you may not always know exactly what we're talking about, but hopefully as we go, you'll kind of build enough background to really understand things pretty well. And just getting the exposure will be useful for you. Our primary topic today is how to turn messy data sets into better structured, more consistent, and analysis-ready data formats. So one of the big challenges that we encounter when we're dealing with data is that data come in all different shapes and sizes and manners of disarray. And so one of our big challenges in dealing with the data that comes in is getting it into some format that we know how to deal with and that we can use for analyses. This disarray can come from all sorts of sources. So it may be that your data comes from someone who has just put things into Excel kind of willy-nilly without any rhyme or reason to where things go. Maybe you're getting data out of REDCap, and REDCap seems to just love to make a million columns with every possible thing that could ever be measured without any real thought as to whether things should be columns or rows. Or maybe you're getting data from really disparate data sources, and some of the data sources store data one way and others store it another way, and you want to figure out how to make it so that you can kind of interpolate between these different data sources. What this talk's going to do is kind of start to explore useful ways to get those data into a consistent format that we can easily work with. That format we're going to talk about today is something called tidy data, which I'll spend some time talking about what that means and why it's important. But a note is that these are often really big and complicated tasks. So trying to get our data into tidy format is often kind of the hardest part of doing data analysis. I know for a lot of my data analytic projects, I think tidying the data, just getting it into some consistent format, is like 80% of the work. And so we're going to kind of scratch the surface on some really useful tools to do this, but just know this is often a really tough process to get things into the format that we want. So as we go, as I said, I'll address a lot of things, but if you have any questions that come up as I'm talking, things don't make sense, you're curious about extensions, things like that, feel free to pop them in the chat and people will be happy to answer them there. And then if there's extra time at the end, we can also have a little Q&A to talk about things as well. So to give a little roadmap about what we're going to cover today. So first I'm going to introduce this concept of tidy. Go ahead.
Sorry, I think we lost the screen share there for a moment. So if you wouldn't mind just sharing your slides again.
Yep.
Thank you.
Is that better?
Perfect, thanks.
Okay, great. Okay, so what we're going to do today. So we're going to first introduce the concept of tidy data. And so we're going to explain what we mean by this data format. So we're all kind of on the same page. And then we're also going to talk about why it's useful to have this kind of structure. And then we're going to talk about some tools we can use to reshape our data. So if we have data that comes in and it's not in the format that we want, how do we coerce it to be in a tidy format? So doing things like, how do we reshape our data? How do we, if we have things that are in rows that we want in columns or vice versa, how do we fix that? Or how do we extract multiple observations from a single cell in our data? Some things we're not covering today are going to be manipulating the data themselves. So we're not going to talk about things like imputing missing data or creating new variables or doing anything that's actually changing the things that are measured. This is really just talking about taking the data and putting it into a different structure so that it's easier to work with. So a lot of the other presentations in the series will talk about how to actually work with the data values themselves. Today's just talking about data structuring. Now, why this is important is that there's this great quote from Hadley Wickham, who's one of the primary developers of the Tidyverse family of R packages. And he has this quote that's kind of an homage to Anna Karenina, which is tidy data sets are all alike, but every messy data set is messy in its own way. what Hadley's saying here is that the idea of a tidy data format is the idea that we can have one structure that's really consistent that we can apply to whatever data we're bringing in. So any data set we can put into a tidy format and it's highly consistent. Whereas there's kind of an infinite number of other possible ways that we can store our data. And if we have all these idiosyncrasies from one data set to the next, it can be really difficult to know how we should approach those data or to even know what those data are going to look like as we work with them. So I can give some examples of this. So I'm going to present here, this is some sample data that's actually built into the Tidyr package. So if you load the Tidyr library into R and just type table 1, you can see these data. And what these data are is a little snippet of data on tuberculosis cases for different countries for different years. And what we'll see is that there's kind of an infinite number of possible ways we could represent the same data set. So for example, here in table 1, what we can see is there's a column for country and there's a column for year. And then there's a separate row for each country for each year. So there's one row for Afghanistan in 1999, one for Afghanistan in 2000, one for Brazil in 1999, and so on and so forth. And then there's separate columns for each of the variables we're measuring. So there's one column for tuberculosis cases and one column for the total population of the country in that year. Incidentally, this is in a tidy format, and we'll come back in a few slides to explain why it is. But we can see here we have lots of data that we may want. So we can now, if we want to know how many cases there are in a given country in a given year, we can go and find that. Or if we want to know the relative number of cases per population in a country in a given year, we can find that as well. We have lots of information here stored in this tabular format. But it doesn't have to be in this format. There's lots of other ways we could have stored this. So for example, in this table 2, we can store the exact same kind of information, but we can store it just slightly differently. So here what we can see is we have a country column and a year column, but if you look closely, you'll see there's 2 different entries for Afghanistan in 1999, and that's because in this case, there's this type column that's saying we're going to identify which variable we're going to tell you about in the next column. And so there's one row for Afghanistan in 1999 for tuberculosis cases, 745, and there's a second row for Afghanistan in 1999 for their population, this like 19 million. And so it's all the same information, but it's stored slightly differently, where now we have twice as many rows because each country we have separate row for year 1 cases and year 1 population, year 2 cases and year 2 population, and so on and so forth. So it's not that we've lost any data. It's not that the actual underlying data have changed, but instead it's that we now are just storing things in this slightly different format. There's other formats possible still. So for example, here in table 3, we can have all the same information again. Now again, we have each country and each year has its own row, but now rather than have one column for number of cases of tuberculosis and one column for total population, those are condensed into a single column. So now we have this rate column that has the number of cases and then a / and then the total population. So again, we still have all the same information, but it's stored in a slightly different format. Or there's other formats still. So for example, in tables 4A and 4B here, in 4A, maybe we store just the cases, and rather than have separate rows for each year, we can have separate columns. So now we only have one row for Afghanistan, and then a column with the number of cases in 1999, and a second column with the number of cases in 2000. And then the next row is a different country. And then in a different table, we can have the same format for population. And so the first row here is Afghanistan's population in 1999, and then in 2000. And in that case, we can, we again have all that same information. Now it's spread across 2 tables. Now it's spread where we have the years in different columns rather than the years in different rows. And so we can ask basically, so basically we can have all the information we want, but we're storing it in different ways. And so it's not that any of these are inherently wrong, but they're all really variable. And often from project to project, we'll see these different kinds of formats. And having our data format constantly change can be really confusing, and it can make it really difficult to work with other tools in R. So if we don't know how our data are formatted, it's hard to apply different functions to those data. And so what we're going to do today is we're going to introduce this idea of one format that's really consistent, that's really widely used within the R community, that can be really useful to make sure that we know what's going on. And this is called the tidy data format. Now that tidy data, we've talked a little bit about the tidyverse, which is that family of packages that Hadley Wickham has helped develop. It's probably the most popular set of packages in R, and it's where the tidy in tidyverse comes from. The functions we're going to talk about today all come from the Tidyr package, which is a part of the tidyverse. Right, all this is the idea that we're trying to make our data in this nice, clean, consistent format. And so having our data consistently formatted is going to be really useful for a number of reasons. Now, first, let's talk about what that consistent format actually looks like here. So tidy data has really specific expectations for where things go in our data. Specifically, in tidy data, each variable has its own column. So each thing that we are going to measure, if it's something different being measured, it'll have a column. We'll have one column for the number of cases of tuberculosis and one column for the total population. Or we'll have one column for liver function and one column for heart function. Each distinct thing has to have its own column for data to be tidy. And then the rows are used for the different observations of those things. So if we're measuring those things a second time, then we're going to put it in a new row. So we'll have the number of cases and the total population in Afghanistan in 1999. That's row 1. And then if we measure it again in 2000, we need a new row. It's a new observation of those same variables. And so it says columns are different things we're measuring, and observations are different times that we're measuring them, or different places that we're measuring them, right? We now measure them in a different country. We're not measuring new things, we're measuring the same things in a different observation. And then each cell can only have one thing in it. So that ratio that we had for in table 3, where we said that had both the rate or both the number of cases and the population in a single cell, wouldn't work. For our data to be tidy, we're going to say everything has to be in its own cell. We don't want to conflate things within a single cell. We want to have them separated out. Now, why this is important is that if we have consistent formatting, it helps us work really well with our data. It helps us make sure that we know what's going to happen when we work with those data. So, for example, often we're tidying our data, we're getting our data into some format so that we can do things like apply a statistical analysis to it, right? We want to be able to run a regression on those data. Well, if our data are always in different formats, it's hard to make sure that we know that the regression is going to know how to interact with those data. Whereas if our data is always in the same consistent, tidy format, then we can be really confident that we know how the function will interact with it. A lot of functions in R are really catered to working with tidy data, right? The tidyverse library of packages is specifically to deal with tidy data. It takes tidy data into the functions and it exports tidy data. It really expects this format. And this is important, right? The tidyverse uses lots and lots and lots of useful tools to do things like data manipulation, but also the ggplot package that's used really widely for visualization is part of the tidyverse and expects tidy data. There's a tidy models package that's used really widely for machine learning in R. It's again part of the tidyverse. It again expects our data in this format. And so having our data in this format lets us work with these different functions and know what they're going to do. But it also lets us know what's going to happen in our data. We're never confused if our data is in a tidy format. We know if there's a new row, that means it's a different observation, right? That now we're looking at different measures of the same things. We know that if there's a new variable, it should be in a new column. And so if we want to find things, it's much easier for us to figure out how to manipulate this data set, or how to search through this data set to know where things are and what things mean. So, okay, with that in mind, hopefully this has at least started to convince you that having a consistent formatting is useful. and hopefully a little bit at least that the tidy format is a particularly useful format for this. And so what we're going to do now is we're going to talk about what do we do if our data aren't in this tidy format? What if we got that complicated Excel spreadsheet or that messy output from REDCap and we need to get it into tidy format? And this can be a real challenge. So like in Hadley's quote from earlier, every messy data set is messy in its own way. So there's often a lot of kind of specifics to your data set that you need to navigate in order to get things into a tidy format. But there's some situations that come up again and again and again, and there's some really useful tools that we can use to address these. A lot of these are in the Tidyr package. And so we'll talk about kind of 3 broad classes of these tools today to explain how it is that we can approach some of these challenges. And the specific challenges that we're going to talk about today, again, are ones that come up really frequently when we're trying to get data into a tidy format. We'll first talk about what do we do when we have multiple variables values in a single column. So rather than each variable having its own column, if they're kind of smushed into one column, right? So that second table we looked at today, where it said that same column, some of the rows had the total cases of tuberculosis, some of the rows had the total population. That column has 2 different types of variables in it. We don't want that. That's not tidy. So we can say, what do we do to fix that? We're also going to address what do we do when we have repeated measures or repeated observations, but they're in the same row. So we have one column for 1999 and one column for 2000, even though we're measuring the same thing in those 2 times. This one comes up a lot. So we'll often see for longitudinal data, we may have every single time point has its own column rather than them being distributed across rows. And then we'll talk about what do we do when a single cell has more than one observation, like in that case where we had the ratios, right? Where now it's not just that one column contains different rows with different variables, but that an individual row in that column has more than one variable in it. Now, one of the really great things about R is that there's always more than one way to do the thing you want to do. There's always more than one way to get your output. But this is also one of the worst things about R, because it means there's lots and lots of different ways to code the same thing. And so it's hard to be consistent. It's sometimes hard to read other people's code. And so what we're going to do is we're going to talk about some standardized approaches to these common problems that can help you kind of build a toolkit to know how to get your data into tidy formatting. So let's start with this first one. So what do we do when we have multiple variables values in a single column? So basically our challenge here is that we need to spread our data across more columns than it's currently in. So all of our data is in one column, but it should be in multiple columns. So for example, when we looked at that table 2, we said in this table, we have the information on tuberculosis rates per country per year. But rather than having one column for the number of cases and one column for population, in this case, instead, what we have is separate rows for the different variables. So row 1 here is Afghanistan 1999, specifically for the cases variable. And then this count column has the number of cases. Row 2 is again Afghanistan 1999, but now this row is for the population. And now this count column has a different variable. There's different types of information in this column. And so that's a problem, right? We don't have, it's not easy for us to know what count means because it means different things for different rows. It's not one variable, it's a variable that's defined in that type column. And so that's not tidy. That's going to work really poorly if we go to run our regression, if we go to visualize things, it's going to be a mess for us. And so we want to know, how do we fix this? And essentially what we want to do is turn this count column into 2 separate columns, one for the cases and one for the populations. And so what we're going to do is we're going to do this thing called a pivot, where essentially we're going to say, let's take the things in this column and pivot them so that we're going to kind of turn it on its side so that now the counts end up in one column, and then we're going to pivot out the populations into their own columns. So we'll have 2 new columns that are going to be spit out. Now, this comes up a ton. this kind of coding happens for lots and lots of different data sets. Some really great hints that this is something you may need to do is if you have a column that specifies what the variable name is. So here we have this type column that is really just telling us what variable is going to be presented in a different column. That's a good hint. Another one is that if we have the column with our data in it, and the data look really, really variable. So for example, if we have different types of data in that column, where sometimes it's text and sometimes it's numbers, that may be a really good hint that things need to be pivoted, that we have too many different types of information in that same column. Or in this case, we have data that's on really different orders of magnitude, right? Sometimes we have things that are in the hundreds of thousands, and then some things we have, and then some rows are in the tens of millions. It seems kind of strange that we have things that are that variable. And in this case, it's because we're measuring different things within the same column. So what do we do here? And so there's a really useful function within Tidyr that's specifically to deal with this, and it's called pivot wider. Right, so again, we're going to pivot our data, that we're going to take that column and we're going to spread it out, and we're going to spread it to make the data set wider. So before all of our data was in one column, now it's going to be in two columns, so things have gotten wider. This function, it's part of the Tidyr package. So if you're working on your data, you want to make sure that you load the Tidyr package, or if you load the Tidyverse package, Tidyr is included in that, so you'll kind of get it for free. I'm not going to include this line of code in the future to save space, but just know all of the functions we're going to talk about today are in Tidyr. And then what we do is we're going to say we're going to take our unpivoted data set and we're going to pivot it wider. We're going to make it into this Tidyr format where we have multiple columns. And we're going to tell this function how to do this. Now, in this case, we're going to save it to a new data frame. I'm just going to call this df. And then we're going to take this pivot wider function, and we need to tell it three things. The first thing is where is the unpivoted data? What's the table or the data frame that has the data that is in the wrong structure? So in this case, that's called table 2. And then we need to say, okay, table 2 has a whole bunch of columns. Which column has the data that we care about? Which has the actual measurements? In this case, that was a column called count. So we're going to say the values from, where do you go to get the values? Well, find the column called count. And that has our values. That has the actual measurements of the variables. And then we need to say, well, where do the names come from? Or what column holds the identifiers for the variables? And to that we say names comes from the column called type. So in this case, type was the column that said, this row is for the variable cases, or this row is for the variable populations. And when we give it all that information, then pivot wider can figure out what to do with it. So we can look at what that looks like. So remember, our unpivoted data set here has this issue that we have a type column that says, for this row, we're looking at cases, and this row, we're looking at population. And then our count has either the number of cases or the population. So it has our two variables conflated, and we want to spread this out. And so we do pivot wider. We take table 2, find the values in the count column, and find the names in the type column. When we do that, we end up with this output that's beautifully tidy. That now it says, oh, you want me to have two different columns called cases and population. It knows that because it looked at the type column and found the different values there. And then I'm going to populate those with the information in the count column. So now Afghanistan in 1999 only has one row with separate columns for cases and population. And Afghanistan in 2000 again has one row with separate columns for cases and population. So it's taken our data and effectively spread them out. It said, now rather than having one column that has two variables in it, now we have two separate columns that have our different variables in it. Our data have become tidy using just one line of code. A quick caveat, if you are a little more experienced with R, you may be used to using pipes to send data from one data frame into a function. You can do that here. That works really well. within the pivot wider family functions. So those of you who don't use pipes, basically you can say, take some data set, send it to a function, and that data set becomes the first argument. If you have no idea what I'm talking about, don't worry about it. You don't need to use pipes, but I know a lot of people do, and so just so that you know, this is something that you can use in this case. Okay, so now what we're going to do is give you a chance to actually implement this on a different data set. So in the exercises folder in that GitHub repo or within the Posit Cloud environment that you had access to through chat, there's a file called Reshaping Data Exercises.rmd. In there, the first set of chunks of code is going to have data exercises on using pivot wider. And so you can look through that, and what you are challenged to do is basically fill in the blanks to figure out how this is working. And so we'll put a little message in the chat to see how you're doing, and then we'll give you 2 minutes to play with it. If you finish it early, great, put a thumbs up on the message in the chat. If you don't finish it in time, that's fine as well. And then we'll reconvene and talk about some other functions. So I'll get the timer started. Okay, not seeing a lot of thumbs up coming in yet, but there's, they're just starting. So feel free to keep working on this. If you are truly stuck, there's a solutions folder also in this, either in the Posit Cloud environment or on the GitHub that has solutions to this. So if you just want to see what that solution looks like, feel free to check out that file and we can go from there. Otherwise, if you have questions, feel free to pop in the chat. But in interest of expediency, I'm going to keep moving along, and so we'll kind of jump to the next topic now. So first, I just wanted to comment. So pivot wider is a really useful tool. In one line of code, we managed to really helpfully get our data into this Tidyr format. I just wanted to note that there's a bunch of other functionality available within this function that we're not going to cover today. So we can do things like rename those columns or pivot multiple columns simultaneously or fill in missing values. These can be really, really useful. And so feel free to click on these links in the slides to see more code documentation or to see some vignettes on how to use this to do some more complex challenges. Okay, so now we're going to talk about a second case where you may need to tidy your data, but it's in a really different messy format. And so this is a case where rather than having one column with multiple variables, we're going to have the same variable that's spread across multiple columns. And so if we remember, one of the goals in the tidy format is that each variable has its own column. And if we measure that variable multiple times, then that's going to be in separate rows. But we often end up with data that doesn't quite look like this. So for example, in that table 4A that we looked at earlier, in this case, we might have a table that includes the cases of tuberculosis in each country. But rather than having the different years as different rows, we could put the different years as different time points. Or we put the different years as different columns. So we have one column for the number of cases in 1999 and a second column for the number of cases in 2000. And this is a problem because we're measuring the same thing. That shouldn't be in separate rows. It should be all in one column. It shouldn't be in separate columns. It should be all in one column, because then we know if we want to find the cases, we go to this column, and that's going to always tell us the number of cases of tuberculosis. Data come in this format lots and lots of times, but to be able to use these data for things like some of the other functions in the tidyverse, for a lot of plotting tools, for a lot of analysis tools, we instead want to pivot this in the opposite direction so that now we have a single column for cases and then separate rows for each individual year. And so we want to figure out, how do we do that? How do we pivot in the opposite direction? Now here we're going to use a really similar function to before, but now we're pivoting longer rather than pivoting wider. So remember, for pivoting wider, we said we're going to take the data and we're going to make it wider. We're going to take one column and make it two. Now we're going to pivot longer. We're going to take multiple columns and put them into rows. So our data set's going to get longer. It's going to get taller rather than wider. And so this is using this pivot longer function. Pivot longer function, again, part of the Tidyr package. And in this case, we need to tell the pivot longer function a couple of things. So in this, what we're going to do here is we're going to take our output, save it to a new data frame that I'm going to call df cases, because in this case, our data just has the cases. And then we're going to say, use the pivot longer function, and we're going to tell it where the data live. What's the unpivoted table that has the information initially? That in this case is table 4A. And then we're going to say, which columns do you want to pivot? Where are the columns that have the data that I want to convert into rows? In this case, there's different ways to specify this. What I like to do is say, give it the name of the first column that I care about, and then a colon, and then the name of the last column I care about. In this case, there's just 2 columns, but say we actually had measurements every year up till 2024, then we'd have 26 columns, right? We want to make sure we have every single one of those is going to be pivoted. And rather than list all 26 columns, we can say, take the column named 1999, and then colon, and then get all the columns up to 2024. And when we do this, we can take our original data set here. We're now, remember the original data set, the challenge was that we had the same variable spread across multiple columns, and we pivot it, and now it puts it in rows. It says, okay, rather than have 1999 as one column, 2000 as one column, I'm going to use those to identify what each row is telling us. So now the first row is Afghanistan in 1999, and it grabs the value from here and puts it in this value column. And the second row says take Afghanistan in 2000 and grab the value from here and put it into this value column. And so now our data are nice and tidy. We have this format that looks great. We have each variable, in this case, we only have one variable, but it has its own row or its own column. And each row is a different observation of that variable. And so that's really handy. Now there's some issues with what the output looks like here, just in terms of quality of life. Specifically, when you run this pivot longer, it defaults to say, when I take the things from these column names, I'm just going to make a new column called name. Now, name doesn't really make sense here because these are years. They're not really names. And then the second column, the one where it takes the values of those variables, it always calls value. And it's true, it's a value, but that's, again, not a very descriptive name. What's nice is that pivot longer has some really simple quality of life tools so that we can fix those column names while we're pivoting. And so in this case, we can say pivot longer, here's our table of data, and then here's the columns that I want you to pivot. But then we can also specify what I want you to name the column where you're going to list those names. So rather than calling it name, we want you to call it year. And what do I want you to call the column where you're going to put the values? Rather than call it value, I want you to call it cases. And when we do that, it fixes it for us. So it took those same data, it pivoted them so that now the different observations are in their own rows, and it nicely named our columns so that things look really clean. So that's the pivot longer function. It works a lot like the pivot wider function, just goes in the opposite direction. It doesn't require a whole lot. You just need to tell it, what am I pivoting? What are the columns that I want you to spread? And then optionally, what I want you to name the output. So great. So now I'm going to give you a chance to do a second coding challenge. So I'll have you go back into that reshaping data exercises, go to where it says coding challenge 2, and then I'll have you do that to try to pivot things longer. Maybe a little bit more time here because I'm had the opportunity to figure out those quality of life tools as well. So we'll reconvene in about 3 minutes to move on to our next topic. So thumbs up the message in the chat once you've reached the end. All right, welcome back. Yeah, so as Rose pointed out in the comments, this one's a little bit tricky because some of these columns have funky names. And so you need to use the weird backticks in order to identify them. So if you got stuck, again, check out the solutions file. You can see the solutions. This is another, I think, important point in making our data kind of nice and clean and tidy in different ways, is that often we need to think about column names. And having weird special characters in our column names can really confuse things. Okay, we're gonna keep moving again to make sure we get through today's materials. But if you are stuck, check out the solutions file or feel free to pop into the R user group and ask us questions. So Pivot Longer, just like with Pivot Wider, has a lot of other functionality that's available that we don't have time to cover today. So there's different arguments to help clean up names beyond what we've already seen. There's things to, if you want to manipulate the data as you're pivoting it, if you need to do different things with missing values, there's really useful tools to do that. And so again, there's links in these slides to the code documentation for Pivot Longer that can explain how to do that, and some vignettes on what pivoting looks like more generally. So the final topic today, we're going to talk about what to do when you have multiple values contained in the same cell. So this is kind of the even more intense case of what we saw of having multiple variables contained in the same column. Now we're saying it's not just within one column, it's within one cell. That cell has multiple things that are talked about in the same place. We saw this in that table 3 example at the beginning, where we had a rate column that includes both the number of cases of tuberculosis and the total population within the same cell. This is a problem because we may want to know those things individually. If all we care about is the proportion, then we could convert that into proportion, but we often might want to know the number of cases distinct from the population. For example, if we wanted to look at countries that have a greater than median population and countries that have a less than median population, and look at the number of cases in those two groups, we need to have population as its own variable. And so we don't want to have things kind of conflated into one cell. We often see this in lots of different clinical data sets. So for example, in some cases, we might have a column that has a list of all the languages that the patient speaks. So rather than having one column for their first language and one for their second language, it might be a single column that has a list that's separated by commas or by semicolons. And that can be really hard to work with because it's saying there's multiple different things that we care about that are all in this same cell. And so we want to know, if our data come in this format, how do we deal with it? How do we get it into this tidy format? And again, Tidyr has really useful tools for this. In this case, there's this family of functions that use the separate command that will help us deal with cases of having data conflated into a single cell. There's 4 primary separate functions that are used really consistently, depending on what we want to do with those data and how they're smushed into that cell together. And so the first thing we can decide is, when we have our data in the same cell, do we want to separate them into different rows, in which case we would separate longer, because now we're going to say we're going to separate it, but we're going to make a longer data set. It's going to be taller. And so that would use the separate longer functions. Or do we want to make them into separate columns? If they should be columns, then we would separate wider. We're going to separate it. We're going to end up with a wider data set. We're going to make new columns. And then we need to specify, how are the data smushed together into that cell? Is there a delimiter? Is there a specific character that separates them out? So is there a comma that we know if there's things on the left side of the column, right side of the column, those are separate values? In that case, we would use the delim functions. So separate longer delim would say we can identify a character, we're going to separate based on that character, and we're going to end up separating into new rows. Or if there's a certain number of characters, the first 4 characters always tell us a year, and then the next 4 characters always tell us a month and a day, we can specify by position and say there's not a specific character, but there's a specific number of characters that we can use to separate it. And so depending on your use case, it's going to vary which of those is most useful for you. So for example, we can ask, in this case, in our table 3 here, we said we had this one column that in each cell has both the number of cases and the number of populations separated by a forward slash. And so we could ask, which of these do you think you would use to get tidy data? And so if you have an intuition, pop it in the comments and we can see what people think. But I'm going to move along pretty quickly here because we're running a little short on time. We can ask basically, how do I want to separate them and what do I need to use to separate them? In this case, we would probably use separate wider delim, because in this case, we want to end up with different columns for our data to be tidied, because this rate column has both cases and population. It has two different variables, and the tidy data format means each variable has its own column. So we want to separate it wider. We want to make new columns. And we want to use delim because there's a character that tells us when to separate. We want to find the forward slash and take the things on the left side, make one column, and things on the right side, and make a separate column. And so the syntax here is just, we say separate wider delim, and then we tell it the table that has the data. So say, we're going to take table 3, we're going to separate something from table 3. And then we say, what column do you want to separate? You use this calls function to say which column needs to be separated. In this case, that column is called rate. We can just specify the delimiter because we're using the delim function. In this case, we say the delim is a forward slash. And then we need to say, what do you want to name the new columns you're going to make? In this case, we're going to call them cases and population, right? Because the first thing you're going to find on the left side of the delimiter is cases, and on the right side of the delimiter is population. And if we do that, it splits it out for us. Again, it gets our data into that nice, clean, tidy format that we want. If you have multiple delimiters in here, this can make more than 2 columns. So if it finds that there's something, and then a slash, and then something, and then a slash, and then something, it'll say, oh, great, there should be 3 columns. And when you give it 3 column names, but it'll separate it up perfectly well. So for example, if you're trying to separate out dates, and you have year slash month slash day, you could specify that and just say, find any slashes and separate them out to make multiple columns. And so this family of functions can be really useful for splitting out these data. Now there's another member of this family of functions that I'm not going to get deep into, but just I want you to be aware of. That's called separate wider regex. So regex is a specific format for dealing with really complex text. So if you have something like you have a year and then you have either a slash or a dash, but you're not sure which, and it might vary from one row to the next, you can write some regex code to tell it that you need to separate things out that way. Regex it's really, really useful, but it's also complicated. Probably deserves at least its own full session, probably even more than that. But if you have these kinds of challenges, check out the documentation for separate wider regex, or click on this link to get more information on how to use regular expressions or how to use regex in order to parse your code for text really specifically. Okay, so quickly, let's sum up what we've learned today. I know it's been kind of a whirlwind. I know I talk really fast. Hopefully it's been useful to this point, but just to give a quick summary, one of the things we've talked about is the idea that there's more than one way to store our data. There's lots of different structures that our data will come in at, and we'll often see multiple different data structures within the same project, right? One table might be too wide and one might be too long, and we need to combine them and manipulate them in different ways. And we specifically said this tidy format is a really useful way to do this, where we have each variable has its own column, each observation has its own row, and each cell contains only one value. We talked about the pivot wider function. When we have too many variables in the same column, when we're measuring more than one thing and storing those data in one column, we can pivot things wider. We can make our data set wider to give things their own columns. We talked about pivot longer when we have multiple observations spread across columns rather than across rows, where now the columns aren't different variables, they're the same variable at different times. In this case, we can say, nope, that should all be in one column. And so we can pivot longer to say, take all those columns, make them into rows instead, and then our data will be nice and tidy. And we talked about the separate family of functions, where we can tidy data sets that have more than one piece of information per cell. So if we need to split things out based on delimiters or based on some fixed number of characters, the separate family of functions works really well. These are just a few of the really useful tools in the Tidyr package. So if you're trying to figure out other ways to clean up your data, check out Tidyr. There's a bunch of other really useful functions within there that can help you deal with some really frequent things that you'll encounter. So I'm going to leave you with one last coding challenge. So in that Reshaping data exercises Markdown file, there's the capstone project that's going to ask you to apply these tools to a more complex data set. So in this case, it's not as simple as writing one line of code to pivot things one way and you're free and clear. But instead, we have a much more realistic, bigger and messier data set. And so this is an opportunity for you to really apply these to this new data set. So I encourage you to explore it. Again, in the solutions file, in the solutions folder, there's the answer or at least one approach to tidying these data. So feel free to look through those. And then make sure to hang on to the solution files to have some good examples of how to use this code in order to work with your data. And so I'm going to stop there. I'm going to stop sharing. We're just about out of time, but if people have quick questions, feel free to pop them in. And then otherwise, I can stick around for a little bit and answer any other questions that people have. But this has been fun. I hope it's been useful for anyone there. And hopefully we'll see a bunch of you in the R user group.